All right, today I'm just going to be going over factoring and basically how that is initially used in math, and then we'll get more complex, and then we'll get to the why a little bit. I don't fully understand it yet, but I'm just on the basics, and it'll play more and more into it. So let's see here. Factoring is, the simple definition is just to break down a number into what it's what makes it. So let's just go over a simple one right here. Initially in math classes, this is what you're kind of asked to do. And so let's see here, we have V2 minus 4. So basically, what can we break this down into? So we have a factoring formula, basically. And so this is the formula right here. So it's A plus B. And this is the formula when there's a minus in there. So A plus B, parentheses, and then in another parentheses, A minus B. So basically, this is A, this is B. Okay? So we need to find these, this, two things in parentheses that can go into this. I don't know the right terminology or anything. Again, I'm pretty new. I'm just learning this to solidify it in my brain. So, let me write this off to the side real quick. So, A plus B, and then A minus B in parentheses. All right. All right, so we need to find two A's and two B's. So V, that'd be V and V. So if you times these, that would equal V squared. 2 and 2. And if one of those is negative, that would equal -4. So pretty simply, V goes in here, V goes in here, so V, first one is plus. And let's see here, we'll use the 2, +2, and then right here we'll use that -2. Because it says right here minus, but really, if we solidify these, that minus is just built in there. So that's really how it is, more so right there. Let me move you a little closer. All right. Probably a little bit better, at least for seeing the equation. All right, so these are equal. All right, so this equals that. So let's verify it real quick. So this goes over foiling. Pretty simple. So we know that this is equal to this. And we just want to verify that. So we can FOIL this, which basically FOIL is a method for computing the product of an expression of the form A plus B, and then another form C plus D, So in this case, that could be considered. But basically, in case you don't know, FOIL, first, outer, inner, last. It's basically all these variables we want to be times by each other. So let's go right here. V times V, so that'd be V squared. And then we go, so the first, V outer, so that'd be the outer 2. So V times -2 would be -2V. And then inner, the I in FOIL, so that would be 2 times V, so that would be plus 2V. And then last, so the last 2, so that would be 2 times -2, which would give us -4. Okay, and then we simplify this. So V squared, and then -2V plus 2V, so those cancel out. So these would cancel out, so that'd be 0. And then what we're left with is -4. All right, there we go. Which is this one we have right here. So we confirm that. All right. So far, so good. You're just gonna be patient with me while I bring up the next one. We try the next simplest. The next simplest one, right here. All right, let's just go here. Sorry. Thanks for being patient again if you're still here. Just making sure, seeing about which one would be easiest. It's a little light on the outside, so it might be a little thundery. Okay, let's just go with this. So right here, we're factoring out a monomial from a polynomial. So basically we have this equation here. So we say we need to factor this. It is for W minus 9 W cubed. All right, so basically we need to find the greatest common factor. So basically, what is in all of this that can be taken out? So right here, what's similar with these two? These two, Well, not a whole lot, because 9's not even, 3 can't go into 4, so 1. So not a lot. But they both have W's in them, so we can factor that out at least. So using the distributive property, we can factor out a W. So right here, if W were to be times, or if we divide W by this, it would just be 4. All right, and then there's a minus right here, and if we took a W out of here, that would just be W 9 squared. Pretty simple. If this was squared, so we could be taking out 2 W's from each one, because this has to be the same right here, these 2 W's. So we could be taking out W squared, only for a little squared above the W. It's a little messy, but you know what I mean. So that would make, so if that were squared, we could take a W squared out, and then this would just be squared right here. And if this were cubed, we could take 3 W's out of each one, which would erase this one. All right, so pretend both of these were W squared, or cubed, W cubed. Basically, we can just take W cubed, then parentheses 4 minus 9. Yeah, pretty simple. And to check that, we just distribute W cubed into each of these. So that would be 4W cubed minus 9W cubed. So that is equal to that. All right. So factoring basics are down. All right. And now we get into factoring with a quadratic, factoring a quadratic with leading coefficient of 1. So basically that means let me write an equation down real quick. So we have, let me write it big for you. So x squared minus 3x minus 18. So not too bad. Right here, okay, so basically we have 3 sections of this. 1, 2, 3. Not too bad. So this simple one with 3 different sections, again, I don't know the exact names of each one, but you get it. So we're just simply asked to factor. So if you see this on a math test, just factor. This is what we do. We need to find, and again, we're using that same equation we used last time. Well, not the same one, but roughly. So this is the equation. So there's x's in this one, so we want to find x plus m, okay, and x plus n. All right. So basically we just want to find two numbers, m and n, that times into this, but add into this. So it can be a little tricky, but two numbers that add into this, or times into this that add into this. So times, let me write it, and the other one. So times into this and add into that. I get those mixed up all the time, so kind of stinks, but oh well. Okay. So it's kind of a bit of a trial and error. This one isn't too bad though, but we can write it into this if we want. Okay, so this is m, this is n, and this is m plus n. So we can instantly think of a lot of things that times into negative 18. So let's go through them real quick. Negative 2 and 9. 3 and negative 6, and negative 3 and 6. Okay, so we know that either m or n has to, one of them has to be negative. Can you see these? Kind of? Okay. So we know that one of these has to be negative. There's a lot you can do. There's also another 2 and 9 and 1 and 18. So there's 3 more, but I would just recommend finding 3 and then trying those out. If those don't work, finding more. We're not wasting too much time, or just do it one at a time. So let's see here. Negative 2 plus 9 is 7. So we're plugging these in right here if you're a little lost. And then 3 plus negative 6 is negative 3. And then and so that's what we want right there. So negative 3 and 6. It's basically or negative 6 and 3. So 3 and negative 6. Those are times. Okay, so again, sorry it's a little messy, but you get it. So once we have two numbers that times into this, that add into this, we can plug them in right into this equation right here. Okay, so x plus 3, and then x minus 6, because this negative 6 turns this into a negative. Okay. All right, so that's the answer, and we can check it by foiling first. So x squared, and then outer negative 6x, and then inner, so plus 3x, and then last, so the last two numbers, 3 times that would be negative 18. So drop this down, that's x squared. negative 6x plus 3x would be negative 3x. And then we just drop this down because that doesn't have an x. So that's negative 18. All right, so this equals that. We've confirmed it. And that is factoring a quadratic with leading coefficient 1. So this is a leading coefficient of 1 right here. So 1 is right here, but usually it's expressed just with when there's just a variable right there, it's just x squared. But that's a leading 1. All right. Looks like I'm sweating right now. My skin's a little oily, but I'm not sweating. All right. And I don't really need to go over this, but if both of the sides of that formula are the same, it can just be squared. It can just be 1, and it can be squared. Just so you know, and that's called factoring a difference of squares in one variable. Okay. Okay, sorry, it's taking a second. I'm just getting to the harder stuff where I'm having trouble right now, but all right, so this is going off of what we just did, but it's called factoring a quadratic in 2 variables. No, let's just go 1 variable right now. Let's see. Okay. There we go. So we're factoring a Sorry, again. Okay, finally. Factoring a quadratic with leading coefficient greater than 1. So we talked about that first number in front of the variable. The last example, that was just 1. So this one is going to be more than 1. So bear with me. I'm trying to solidify this in my mind. It's taken a lot of trial and error, and I haven't simplified it yet. But let's use this example. All right, big for this one. 6x squared plus 7x minus 20. All right. So basically, it's a big 6, but oh well. Basically, we want to find the answer to, let me write this in red. The same thing as last time. So, parenthesis x plus m times x plus n. And this does have, so this is really finding a coefficient greater than 1 but less than 10. Yeah. Yeah. So basically we need to find something that times into this, adds into this, but incorporates 6, which is kind of confusing, but that's all right. So there's 2 equations to this. So 6 can be divided into 2 different things. That's why we have 2 different equations. I'll write the next one just a second. We have 6 times 1 or 3 times 3. So in the first one, 1 would go in front of x right here. Anyway, so 1 would go in front of the coefficient as the coefficient right here, and 6 would go as the coefficient right here. So that means the next one, and it could be, can you see up here? Not really, okay. So, or, you can see over here, right, if I'm not in the way? Okay, or we could go, or 3x plus m times x, times 3x plus n. It's hard enough to understand it myself, but explaining it's a bit harder. Okay. So it can be either of these 2 equations, which makes it even more difficult. All right. So this is case 1, and this is case 2. Let's draw it out. I'll stick with red for a lot of things. Okay, so we do the same thing we did last time. Where does the screen go? Over here, kind of? Okay, so we make 4 different columns. So 2, 3, 4. And this is M, N, and then this is case 1. So case 1, this one, 1, 2, which we need to find. Sorry, I'm just trying to think of how I'm trying to like teach myself and do it at the same time. Okay. Which is n plus 6m, and then so that's case 1, and then case 2 is 2n plus 3m. Okay. Yeah, because, no, so I messed up. So this one would have to be a 2 right here. Because 2 times, freak. All right, so 2 times 3 is 6. All right. Jeez. All right, let's start going through these. So we still just need to find products of -20 through m and m. But through this one, we need to find the whatever two numbers added to it with either 6 or 2 times 3. All right. Jeez. Freaking crackers. All right, so -4 and 5. So let's use this example. That equals 20. But plugging in here is only equal to -19. Because that's -24 plus 5 is equal to -19. Okay, and this one right here is equal to -2 because that's -12 and 10, and adding those together is 2. Okay. I feel like we're onto something. There's tons of possibilities for -20, unfortunately. So you kind of have to go through trial and error, follow up for all of them. But -5 and -4 equal to -20, which in this one is 26. And this one is 7. So it looks like, and I skipped ahead because I already know what the answers could be, but you could go 1 and -20, -1 and 20, 2 and 10, all the 4s and 5s. But after trial and error and saving time, you could spend 10 minutes doing this. You can spend 10 minutes doing this, finding this 7. It goes right here. So we know that option 2 is the right answer because it fit into this one. Okay, so how do we write this out? Pretty simple. We go 3, and then we 3x, n, which is 5, so plus 5, and then 2x, and then the n, which is -4. All right, sorry, this is all messy again. But basically, let's check that just to be sure, because I mix these up all the time, and sometimes I have to even do trial and error further, and just to check it on a test or something. It doesn't take too long compared to the whole process. So if you're spending 20 minutes doing this, you can spend 3 minutes checking it by foiling real quick. All right, so first, 3x times 2x is 6x squared. First outer, so that's going to be -12x inner. That's going to be plus 10x. And then last two numbers in the way, but that's kind of all right, is -20. So there's no, I forgot what the word is, but nothing that can be times by 6x squared. So that just drops down, 6x squared. Now these two, -12x plus 10x, wait, did I do that right? So -12. -10. sorry, just one sec. Let's check that. Yeah, so right here, this is why I like to check things, because I get them mixed up all the time. But you can probably do it a lot better than I can. All right. So I wrote that down wrong. Basically, the right answer is 2x plus 5 times 3x minus 4. All right, get rid of all this other crap. Simplify things a little bit. All right, so sometimes I get it mixed up, so I have to check it to reevaluate things a little bit. Okay. Let's change. So this is the right answer. To verify that, first, so 6x squared outer, which is negative 8x, yeah, inner, so 5 and 3, so that would be plus 15x, and then the last, which is negative 20. Okay, so again, this drops down, 6x squared. That now equals plus 7x. Okay, then this drops down. So that's negative 20. Holy cow. All right, so I have troubles with that. That's why it took me 20 minutes to do this problem. That equals that. Cool. Not a lot of other things. That's pretty much the hardest part of factoring. Right there. And of course, I mean, I said with a coefficient greater than 1, you can do more, but you're going to do a lot more trial and error. That's the only thing I meant by that.